shooter and a robot built around a ball shooter.
Okay, so the ball shooter here, you can kind of see a little bit its early stages here, and Dane was helping us out with that. But what we decided to do originally was the first design was something designed where the gears would mesh and then unmesh from each other, which didn't really work out too well because the gears are aluminum, so they ground down after a while. So we switched to another design that uses a linkage that starts in the center. So can we tip that on the side actually? Yeah, tip it on the side.
For competitions, they gotta be really careful. We don't want to break anything.
Yeah. Okay. So as you can see here, there's a peg here, and when this gear rotates, it pushes this down and around, and once it hits the bottom here, it springs up, and it springs up, and then it shoots the balls up with with the plunger there. So what we found is that it lets us score like super fast compared to a batch system with a lot of other teams did. Because you can only pick up 5 balls at a time. So this lets us score a lot faster than those teams could. Yeah, once we get that all fixed. But our goal here is to go to super regionals eventually, which is after state. So we hope to do well enough tomorrow to get to super regionals. And Isaac's gonna set up the telly out here.
Where's the competition tomorrow?
It's in Kent at the Showwear Center. There we go. So that's it.
Yeah.
We didn't know.
Here, just
Yeah, so what's really cool is I think we are the only known continuous working system in the local vicinity, and it really helped us out at regional competitions. We're in the finalist alliance, and we got fifth place for the Inspire Award, which is considered the highest award they can give to a team. So maybe we'll get you a little demo here.
Yes, if you want to drive, we can maybe look at a demo.
So while they're setting up driving, I guess I can talk about some of the other stuff that we've done with this robot. As you can see, there's kind of a lot of really colorful plastic parts on here. All of those up in the upper arm assembly here are actually 3D printed. So we 3D printed those at our school and designed them all in SolidWorks. We know that some of you use SolidWorks quite often. Yeah. Yeah, so that's kind of how fast we can score, which is really cool.
Pretty fast.
Does it automatically know how tall your tube is?
no.
No, it doesn't. Well, I guess so
Maybe just in terms of automated stuff, you just brought that up. We could talk a little bit about autonomous. So another key part of this game is autonomous, and what we have is we got a 2-minute driver control period where it's us driving like you just saw. We basically just do what we just did, and this is a pretty good scoring rate. So we get this tube filled up by the end of the driver control period. The autonomous is first though, and what we do is we've got a gyro sensor on this robot, and the wheels all have encoders on them. So there's a ramp that we have to run down, and we push down using the gyro sensor, and then keep going straight using a proportional sensor on that gyro sensor, lock onto one of these tubes, score in it, and rotate, all using the autonomous program. So the reason why this is pretty cool is because even if a robot if a battery is drained, or another robot is pushing against us, we'll still be able to make all these turns and make all these distances, because everything is happening in relation to the gyro or the encoders, not like time. So even if we have like a really low battery, this will all still work. So that's a pretty cool thing we've implemented in our autonomous program this year.
Anyone else got anything cool to say about that?
Oh yeah. Yeah. So we found that because the draw length is so short, so the springs are right here. So it's only like 3 inches of springs. We found that we have to pull like 45 pounds of force to actually shoot it that high up. So we had a whole bunch of different troubles at first because it wasn't shooting as high. So I think there's 4 springs in there that are very stiff, and you can probably shoot like 5 feet in the air if there wasn't that on it. So. Do any guys have any questions about the programs in general? Or first?
How did you hook up the controllers to the controlling stuff?
So Isaac, each one. So Isaac sets limits for each button that you have to do, and it's custom for every single year. But the joysticks are essentially the basic color controllers. They're pretty easy to use.
And right now, we're running this entire system off of Bluetooth, but during the competition, we use, we're using Samantha right now? Oh, okay, so we are. So we use this little module that you can sometimes see on the front with all the blue, white, and red lights on it. And that's our Wi-Fi module. And while kind of like the main brains of this robot happens to be a Lego Mindstorm, it can use Bluetooth, but Bluetooth is really unreliable. And so in past competition years, they used Bluetooth, and it was just really hectic because it would never work. So a few years ago, one of the first mentors came up with the idea of this Samantha module, and it became standard for all competitions. So it's really helped out because Wi-Fi is way better.
So right now, one of the challenges